Welcome back to Physics with Mr. Peacock. Here we are looking at how to solve a friction problem with vectors going in 2 dimensions. So we're here on page 8 of our Unit 4 notes pack, and we're looking at this friction with vectors example. So here we have a box, and it is being pulled by a force, and that force is at an angle. And it tells us that the box is sliding at a constant velocity, and we need to find the coefficient of friction. So we are going to follow our 4 steps. Draw the free body diagram, find any components, determine the net force in the x direction and the net force in the y direction, and then solve, and we'll add using the friction equation. So let's start with step 1, my free body diagram. The first thing I know is I have gravity pulling down on that box because the box is on Earth and I see gravity pulling down at all times. I know that I have some normal force because the box is pressing down on the desk, and the desk is pushing back up on the box. So that normal force is the desk pushing back up on the box. Then I know that I have friction here, or sorry, not friction, but I know that I have a tension force, F, shown in my picture, and that is happening at an angle. And that angle is 20 degrees. 20 degrees. And then the last thing I know is that there is some friction force because it says that the box is moving at a constant velocity. If it's moving at a constant velocity, I know the forces have to be balanced. So if I've got this force pulling to the right, there must be something pulling to the left, and so that is our force of friction. So we've drawn our free body diagram. Now we need to find components. So if I show my force that's here at an angle, that's going to have 2 components. It's going to have a component in the x direction and a component in the y direction. And I know that x is going to be the overall force times the cosine of the angle, and I know that y is going to be the overall force multiplied by the sine of the angle. If you need help with specifically how we found that, I would go to the video about vectors and about adding and breaking down vectors. But those are our components. Check. Now we need to determine the net force in x and the net force in y. So we're going to start with our net force in y. We know that this box is not accelerating, it's going at a constant velocity up and down. So the forces have to be balanced up and down because it's not moving, it's not launching off the table, it's not sinking into the table. So we know that those forces must be balanced in the y direction. And now we're going to add all of the positives and subtract all of the negatives. So we have our normal force plus this y component of the force that points directly in the y direction. Both of those are positive, and gravity is negative. We see gravity negative here. And all of those together equals 0. Now we're going to look at the net force in the x direction. We know that it's going at a constant velocity. If the constant velocity, that means the forces are balanced, so the net force has to equal 0. And we're going to look at everything going positive in the x direction. And I look at my free body diagram and I see that it's this x component because that's traveling in the positive x direction. So Fx. And I know that friction is negative. because it's pointing in the negative x direction, equals 0. So I've done that. Check. Now I think about what is the question asking me for. It's asking me to find the coefficient. I know that my formula for friction is the force of friction equals the coefficient times the normal force. So what I'm going to do is I'm going to take this whole thing here and substitute it in to this equation. So I'm going to see that the x component minus the coefficient multiplied by the normal force equals 0. Then if I add that to the other side, I know that the x component equals the coefficient multiplied by the normal force. And I'm trying to get the coefficient by itself, so I'm going to divide both sides by the normal force, and that will tell me that the coefficient is equal to the x component divided by the normal force. Now I need to figure out what is this normal force. And to figure that out, I'm going to look over here in our y direction. We need to get normal force all by itself. So we're just going to subtract the y component from both sides and add the gravity to both sides. And that will give us normal force equal to the gravity minus the y component. So then I can take all of that and I can put it in here for normal force. And I'll have the coefficient is equal to the x component divided by gravity minus the y component. Now the last thing I'm going to do is I'm going to sub in the things that I know when I found the x component and the y component and put those into the problem. So I'm going to see that the coefficient is equal to the force times the cosine of the angle divided by the gravitational force, which I know is the mass times little g, minus the force sine theta. So I've taken my x component, which I found here, and I put it in. I took my gravity, which I know because Fg equals the mass times little g. I've plugged it in here. And then I have my y component, which is f sine theta, which I've plugged in here. Now, if I wanted to plug all of my numbers in, I can. The coefficient is equal to 100 times the cosine of 20 divided by 50 times 10 minus 100 times the sine of 20. And I'll need a calculator. Actually, on this video, because I'm running out of time, I'm not going to solve that out. But if we were to solve that out, we would find our coefficient of friction. Remember to be the leaders your community needs and deserves. Choose to be great and make your dreams come true.